Welcome to English for Professional Mechanical Engineers. It's so nice to see you again. My name is Yiji. After lecturing on nanomaterials and its risks, I'm going to introduce another occupational hygiene issue, the workplace exposure to nanomaterials. This is the outline of the previous section, nanomaterials and its risks. I argue that the size matters. When materials are the nanoscale, they demonstrate different properties compared to large particles. Next, we mentioned what are nanomaterials, the definition. Then, what are the promising applications of nanomaterials? Finally, what are the risks of these nanomaterials? In this section today, we will focus on the issue in relation to occupational hygiene, the workplace exposure to nanomaterials. Here we have a worker who is handling nanotube materials. He is handling raw single-wall nanotube material, which is promising to be widely used in making many electronic devices. However, is it safe for the worker to handle the nanomaterials? So far, there is no evidence-based proof for nano-specific occupation medical screening. Furthermore, there is no general medical screening basis for epidemiological studies either. Therefore, there is either no foundation or general medical screening for workers who are exposed to nanomaterials. There is no large scale of systematic study for all kinds of nanomaterials at the workplace. Here are some research results of nanomaterials on animals like chimpanzee, squirrel monkey, rats, and so on. The health issue of nanomaterials has been studied for a long time, but it is still hard to draw conclusions about occupational safety for the nanomaterials. Here, there is a research result based on carbon nanotube. It is the material which shows the photo of the electron microscope at the beginning of this video. Exposure to carbon nanotube material aerosol release during the handling of redefined SWCNT single-wall carbon nanotube. This research includes field study and lab study. In the field study, it assesses airborne and thermal exposure to SWCNT single-wall carbon nanotube, while people handle the unrefined material. The concentrations generated while people handle the material are very low and always less than 53 micrograms per meter cubic. These photos are taken by the electron microscope. They are the characteristics of airborne nanotube particles. The photo on the left is the expected morphology, while the photo on the right are real situation, the predominant morphology in the field study. In comparison with the expected morphology, the field sample would be aggregated or combined into a big one. So, what is the significance of it? The field study reveals that what we see in the lab is different from what we expect in the field. However, most research results so far have been based on the lab studies. That is something important and meaningful to notice. Okay, these are some conclusions from the field study. But how about this in lab study? It shows SWCNT single-walled carbon nanotubes can release fine particles with sufficient aggregation to our immune system. Well, what does this mean? It means single-walled carbon nanotubes are probably not safe to the body. As a result, our immune system has a response to fight for it. What are the categories of nanomaterials which may appear in the workplace? 1. Metal oxide. 2. Nanoclays. 3. Nanotubes and spheres. 4. Quantum dots. Except for the carbon nanotubes, what materials are included in these 4 engineered nanomaterials? 1. Metal oxides include ceramics from oxides of zinc, iron, and zirconium. 2. Nanoclays include naturally occurring plate, like clay particles. 3. Nanotubes and spheres are mostly used in coating, like single-walled carbon nanotubes. 4. Quantum dots are used in exploratory medical diagnostics and therapeutics and self-assembly of nanoelectronic structures. So, how are these nanotechnologies applied in our life? As they affect human health? Should we or can we afford to use these advanced technologies in the daily life? What has other people say about this? Once an early biomarker of a disease or the dysfunction is identified, then scientists can use targeted pharmaceutical or gene therapy to correct faulty components. Some people think nanoparticles are too useful not to enter the human environment. That brings us to the next point. Now, let's look at the health effects which have been identified so far by scientists. There are 2 major conclusions. First, some nanomaterials like multi-walled carbon nanotubes, MWCNTs, have shown asbestos-like effects. It reveals that some nanomaterials have long-term effects on human health. Second, the toxicity can depend upon the size, shape, surface, charge, and age of the nanomaterials. Theoretically, there are 3 routes of nanoparticles to enter our body. 1. Inhalation or respiratory exposure. 2. Absorption or thermal exposure. 3. Ingestion. The first route of exposure to nanomaterials is inhalation. Nanomaterials enter our body by breathing. Inhalation is the major exposure route, and it is the most concentrated and produces the strongest effect. Inhaled airborne nanoparticles may be deposited in different parts of the lung. Moreover, they do not only influence the lungs, but also it can travel to other parts of the body. Inhaled nanomaterials may travel to other organs and lymph system via bloodstream. What effects will happen to workers if they are subjected to respiratory exposure? The most common respiratory effects are chronic toxic and carcinogenicity. People easily get inflammation, fibrosis, and tumors. Theoretically, small particle size and increased surface area would increase toxicity. The smaller the size, the higher the risk. Just to repeat what I said earlier, there is still no clear evidence of toxic effects on organs other than lungs. The last two theoretical points are just speculative conclusions. The second route of exposure to nanomaterials at the workplace is absorption by the skin. However, the study showed different results to the previous one, respiratory exposure. Firstly, there is from little to almost no penetration beyond surface skin layers. Secondly, it does show penetration of flexed, damaged, or diseased skin. Third, the penetration of intact skin is only within 8 to 24 hours. It has no long-term effects. Eyes are also an exposure route. So, what are the conclusions to the workplace exposure to nanoparticles by dermal exposure? Again, there is little research available. Secondly, the effects on healthy skin are not observed, except for sensitization. Finally, the barrier function of the skin can be breached by mechanical strain and lesions. So, the main points on this page are 1. Little research has been done. 2. Healthy skin is fine to nanomaterials, except for sensitization. And 3. Mechanical strain and lesions. The final route of exposure is ingestion. Supposedly, it should not happen except for poor work practice. Something like eating or smoking in the work area can result in hand-to-mouth transfer. In addition, ingested nanoparticles do translocate to other organs. What are the overall conclusions to the workplace exposure to nanoparticles? What are the safety hazards? First of all, there is acknowledged insufficient volume of research. Secondly, fire and explosion are the main risks which have been described. 3. Workers should pay attention to nano-sized particles because of the large surface area, easily electrostatically charged, and long-term distance airborne transportation. 4. Some metals, like aluminum, have minimum ignition energy. It is so low that it can be ignited by static electricity. Therefore, its nanoparticles are very inflammable and explosive. However, agglomeration and surface oxidation reduce explosive properties. Finally, presence of flammable materials would increase the risk level. This is a list of the effects from nanomaterials testing exposure. For your reference, you may take a look. It includes cancers, transfer to different organs, and so on. It's about time to give another assignment. It's going to have 3 products regarding nanomaterials. I would like you to study what they are and when nanomaterials work in the products. Furthermore, is it safe for the workers and customers? Case study number 1, Magic Nano. Case study number 2, skin cream with fluorescence. Case study number 3, Nano Silver washing machine of Samsung. Based on the powerful applications and limited research support, these are recommendations on occupational hygiene. They require clear definitions on nanomaterials at the workplace. Policy with more precaution. Label nanomaterials on the products. No data, no market. Analysis of the costs and the benefits of any new products. Systematic research on the health and environmental risks. Finally, enforcement by inspectors. This is a list of information available on the internet for those who would like to come to a better understanding of it. Well, that's all from me today, and this is the end of section. Workplace exposure to nanomaterials. Hope you have learned something useful in this lecture. See you in the next video. Goodbye.